Right, this is the last question, question 6 on your CAP5 test. What is an antigen? And this is just antibody generator. So which bit of the baddie goes on to provoke the immune response. And so we're looking for really, it's usually a protein or a glycoprotein or something like that. It's something that stimulates the immune response. So it's a molecule, e.g. protein or glycoprotein. I can spell glycoprotein. Glycoprotein that stimulates an immune response. Describe how B lymphocytes respond when they are stimulated by antigens. So we don't need the bit about them being stimulated, we just say what happens next. So they start dividing to form clones, which produce these plasma cells, which make the antibodies, and then might eventually make memory cells. So we just need to put that into those last steps into words. So first of all, they divide by mitosis, and this is just stuff you should have committed to memory. These would then form clones of those B lymphocytes. These then go on to form plasma cells. These form plasma cells, and then you know that plasma cells make antibodies. Plasma cells make antibodies, and then eventually we're going to get some memory cells being made as well for a secondary immune response. And plasma cells make memory cells. So no other options there, 4 things for 4 marks. Part C, the diagram shows components of HIV, and you should know this diagram. Suggest which labelled component of the virus is more likely to act as an antigen. Well, we've just said the protein or glycoprotein in part A, so we just need to give a reason. And the reason is a little bit complex because it needs to be something that the body recognises as foreign, which might not be some of these components. So, for example, phospholipid bilayer, we wouldn't recognise that as foreign, for example. So we're going for glycoprotein. Because it's a different shape to the body's own proteins. So it's a different shape to the body's own proteins. And other bits might be the same. So, for example, phospholipids would be the same in the body. But you only need to say that first bit. And then we've got a cell of HIV infected is 15 micrometers. 15 micrometers in diameter. calculate how many times larger this cell is than a HIV particle. Right, okay. So we know how big the cell is. How big is this particle? Well, the only bit of information we've got to go on is this 20 nanometers scale bar. So we want to know how big this virus is. So what's the diameter? Well, let's try and so it would be about there. So we're looking at possibly on my diagram, the diameter of HIV is 71 millimeters. Okay, I'm going to measure this scale bars. It's the only thing I've got to go on, and I'm going to have there is 18 millimeters. Okay, now I just need to go from that to that, and so to get my number from 18 to 71 to scale it up, so to get from any number to another number, I'm going to go 18 divided by 18 times by 71, and that's to convert those numbers. And I need to do the same with my 20 nanometers. So my 20 divided by 18 times by 71. 20 nanometers divided by 18 times by 71 is, round that off, to 79 nanometers. So I get the diameter of the HIV as 79 nanometers according to my diagram. And then it says how many times bigger. Well, how many 79 nanometers go into our 15 micrometers of our cell? So calculated HIV diameter is 79 nanometers. The human cell diameter is 15 micrometers. So we've got different units here. Let's convert them into the same units. It's easier for me to convert 15 micrometers into nanometers, just times it by 1,000. So 15,000. So now we're going to work out how many 79s have we got in 15,000. So 15,000 divided by 79 is 189. So I get, so we're going to go 15,000 divided by 79, and I get 189.8, so 190 times larger. The mark scheme actually says 187.5, but it's got the HIV as 80 nanometers, so slightly different to me, slightly bigger. But sometimes these photocopies slightly different sizes. If you've got anything in this area, then you're going to be right.